As we discussed in class, the linearization is your tangent line approximation. So there's a formula for the linearization that is presented in textbooks. They say f of a plus f prime of a times x minus a. And the reason why they present it that way is that actually can be extended to higher degrees, which will then give us our Taylor polynomials. So that's kind of the reasoning behind why it's such a weirdly written, like instead of having f of a at the end, they have it at the beginning and so on. It's because it's going to, if you were to continue to higher powers, you would have these Taylor polynomials. But with that said, in Calc 1, what we want to do is we want to just have our linearization tangent line approximation. Remember that the function will be given, and then you'll also be given the center for the linearization, and that will be an x value. So that is basically the center of the x value where we're trying to find the tangent line approximation. Now, you are more than welcome to plug it into this formula. So one way of going about it is you could say your linearization at x is going to be f of 0 plus f prime of 0 times x minus 0. So you could replace all of the a's in the linearization formula with the center here of a is equal to 0. And then you could compute this. So if you plug in f of 0, you're just going to get 0 plus our f prime will be 1 plus 4x to the third. If I plug in 0 into f prime of x, I will get 1 and then times x minus 0. And so that just gives us x. Okay, so that is one way of finding the linearization. The other way that you can find the linearization is you can use it or think about it in the context of the tangent line approximation. So what you could do is you could go through and find your tangent line. So remember that we have y minus our y1 coordinate, and to get our y1 we plug in the center into our original function. So you would have 0 plus 0 to the fourth, and that would give you 0 for the y1 coordinate. Equals, and then we have our f prime of x. So f prime of x we got as 1 plus 4x to the third, and so then f prime of 0 will just be 1, and then times x minus 0. Okay, so either way, like if you look at this, you're coming up with the same numerical answer. The format does look different though, and so for the tangent line approximation, you don't want to leave it at y minus 0. You want to actually call it the linearization. So what I'm going to do is after I find the tangent line, I am then going to solve for y, and then that will be my L of x. So in this case, if I solve for y, the 0 drops out. I just have 1x, and so then I would say that the linearization L of x is equal to x. Okay, so either this formulation or you could use this formulation. They are fine. I do not care about on the test which one you do, but just keep in mind, like the reason why they're presenting it in this format is because of Taylor polynomials, because later on in Calc 2 you'll see how you can extend it to higher degrees. Okay, but again, either way that you do this, your final answer is going to be L of x is equal to x.